Good morning, everyone, and welcome to the Hydrogen Fuel Cells and Batteries Group exhibit. We are in the hydrogen production and energy storage theme of this morning's presentations. And next up, we have a talk on hydrogen safety and market familiarity. While we listen to this, I invite all of you to please take a seat, enjoy a coffee or water while we listen to this great presentation. I'd also like to welcome all of the viewers who are watching our live stream. And on that note, this presentation will be available on the Hydrogen Fuel Cells and Batteries website in case you miss any information first time around. So here we have today the Vice President of Hydrogen Automotive from Hexagon Composites, Mr. Rick Rashilla. Thank you.
Vielen Dank. Vielen Dank, Helen. Und guten Morgen, Deutschland. Heute, mein Deutsch ist nicht so good. So today I will speak in English. Thank you very much for the opportunity to speak today about hydrogen safety, especially in the storage tank area, and also market familiarity for hydrogen storage, and we'll take a dive into both of those topics. First, we'll talk a little bit about who is Hexagon. Hexagon is a company that has been around for a very long time, over 55 years of storing gases in lightweight cylinders. We have headquarters in Norway, manufacturing centers in Germany, Norway, also in Maryland in the USA, and in my location, Lincoln, Nebraska. We make plastic-lined Type 4 tanks for methane and for hydrogen, and in some cases, other gases. We also make Type 3 tanks, which have a metal liner for many manned spacecraft applications and also unmanned applications. We invite you to stop by booth 60, B60, for a closer look at these products. One of the best opportunities to talk about hydrogen in Europe is here at the Hanover Messe. It is the largest gathering for such an activity, and the audience is not just folks from Europe or from Germany, but a global marketplace. And this marketplace needs the information regarding market itself and also some recommendations on safety and how the industry for hydrogen containment keeps itself in a safe fashion. So each of you will be an ambassador if you are involved in the hydrogen activity, such as fuel cell value chain or the hydrogen creation. And each of you can go forth and speak a little bit more about what the market is in hydrogen and how the market safety occurs in the background as a foundation, thanks to some of the important codes and standards that are created in the business. So my belief is that this market information is in the front. Many people are excited about the hydrogen market itself, especially for fuel cell vehicles. And underneath that, almost in an invisible fashion, is the activity that keeps the market safe so that products do not experience any difficulties in the field and are operated in a very similar fashion as a gasoline or diesel-powered vehicle. In the middle are the steps that lead one from discovery of a new market or a new technology through the actual deployment or application of that by participation in the market. And on the left-hand side, we look at the steps that are needed in order to accomplish a deeper dive into defining the market. First, we must select a market segment. Maybe it's fuel cell powered buses, maybe it's fuel cells in general. But once that market is defined, we focus on deep knowledge for that particular market segment, not a broad market area, but a very focused area, so that the information that is developed is useful, it's timely, and you can have high confidence in the outcome. In order for that high confidence to occur, the market information must be tested, and then once it's tested, double-checked in one fashion, let's go out and test it in a real-world fashion in different geographic locations and different technical applications. Once that certification or validation has occurred, you can observe developing trends in different locations or marketplaces. We might find that in India, it's important to store low pressure, but a high quantity and inexpensive type of hydrogen, while maybe in the EU, we want to have very, very high pressure and a great quantity of fuel on board. So we test those applications. And then finally, we think about alerts. let's make sure that the market expectations are as we believe they would be, or we have a course correction if needed when new information comes up. On the right-hand side, we think about safety itself in the business, and the same steps are required. Let's define the new product application, or for example, the size of a tank or the pressure of a tank. Once that is known, we can specify how much we wish to contain in terms of kilowatt hours, and then let's test that product. In this case, the tests would be an initial demonstration that the technology selected is suitable. After that is proved successful, the next step would be to rigorously certify and validate through a source of many tests that come from independent third parties to guarantee that that technology is able to work properly. And then during the course of use, we must sense whether the tank is operating at the right pressure or the sealing surface is as it should be. We might have hydrogen monitors on board, temperature sensors, pressure sensors, and all those could lead to a situation where an alert could be provided if there is some unusual characteristic that's manifested. All these systems bring a mature activity into place and allows, in this case, the technology to participate in the markets by being deployed across the globe. So these steps, we take a little bit further look into how they're affecting in the tank storage arena. The value chain for hydrogen begins with hydrogen creation. And our last speaker, Mr. Anderson, talked about Nell's activity in actually making hydrogen in an electrolyzer application. On the far left-hand side, you see a soccer ball, which contains generally 1 bar of pressure as the FIFA maximum limit. The Nell electrolyzers will create hydrogen generally in a 2-bar range up to a 30-bar range. And that low pressure must then be compressed and converted into much higher pressure so that a vehicle that operates on 700 bar can be fully filled, perhaps from a filling station that has a 1,000 or a 950 bar pressure bank. So as we march across vehicles, whether they're passenger vehicles, buses, trucks, trains, marine ferries, or the ground station cylinders, the tank pressure must be generally increased to ensure that we have a full filling pressure on each one of the vehicles. And in order for all that tank safety to take place, we must perform several different tests to ensure that the product is indeed as we expect it to be. There are many words on this chart. On the right-hand side is a list of most of the hydrogen specifications that are in the world today that are used to ensure tank storage safety. Some of those are local requirements for certain markets like the EU or North America. Others are international standards, especially we think about the Global Technical Regulation, also known as UNECE R134. And the chart of tank standards throughout the world is so busy that it takes a long time for anyone to sit down and understand what standards should my product meet in order to be deployed in a certain country. Participating in the creation of those standards helps create a safe market that can also use new technology. And just as an example, if you are a vehicle maker or a vehicle operator and you refill your tank to a 700 bar level, you should know that the tank that's operating in your vessel, as shown in the lower left-hand corner, tells us that for a 700 bar operating tank, this tank, although your vehicle keeps it at 700 bar, it's actually designed to be overfilled by 25% to 875 bar, so that when it's got warm gas in it, it can handle additional pressure. Before each one of those tanks were to leave a factory, it also experiences what we call a proof pressure. And the proof pressure is 150% of the operating pressure, or 1,050 bar. And every tank experiences that test so that when it's deployed on your vehicle, it has already seen more pressure than it should ever see from a hydrogen fill station, which may deliver the 875 bar. In addition to that, during the certification and designs, testing on all the previous pages certification and regulations, we must demonstrate that a tank that operates at 750 bar must rupture above a factor of generally 2.25 or 2.35 if it's reinforced with carbon fiber. If the tank is reinforced with fiberglass, those two materials have a different ability to withstand long-term pressure exposure, and they must burst at an even higher level. So that minimum rupture pressure assures that if you are a vehicle driver with a 700 bar tank, the design of the product in your vehicle has already shown that it can withstand much, much higher pressure, and even after it's been exposed to some type of damaging contaminants or a number of high cycles. This wall thickness of the carbon fiber or the fiberglass varies based on the pressure, but regardless of the use pressure, we must withstand that type of a threshold during the actual acceptance testing of each tank and during the more rigorous testing of the design during certification. From a market familiarization standpoint, I really want to know how much will hydrogen grow in the future. Many people talk about it. There are some barriers to that growth, but we believe that hydrogen is a very promising technology for the future. And if we look at how the battery electric vehicle market has grown just in the last 7 or 8 years, on the left-hand side you can see the actual market penetration for battery electric vehicles. And in 2016, for the first time, 1% of battery electric vehicles were shipped out of the generally large number of light-duty vehicles shipped each year, more than 1 million vehicles. On the right-hand side, in the lower bar chart, you can see a prediction for hydrogen fuel cell vehicles from an adoption rate growing to more than 1 million vehicles at a 1% market penetration rate out in the year 2028. This curve is slightly flatter than the battery electric vehicle curve, but we believe that it's a conservative case and it represents a large quantity of market potential as shown on this bar chart, and that large quantity of market potential is based on varying degrees of market penetration, roughly 1% for the light-duty vehicle market and perhaps 10% for the bus market, where we see more federal funding across all countries and locations, boosting the ability as well as the clean emissions requirements to ensure that buses are not polluting the environment. Many of the regulations that are requiring low-emission vehicles will either help us grow this dramatically or, in one sense, similar to this growth across the alternative energy market, in this case, specifically for the hydrogen vehicles. There are some drivers to this. One certainly is low emissions. Another is hydrogen fuel cell vehicles offer fast fill and longer range, perhaps, than some battery electric vehicles. We also believe that the fuel cell cost will be reducing as quantities increase, and we see a very successful application in many new markets of the fuel technology for light-duty vehicles, buses, trucks, and also in the marine market sector. I talked about testing on that first slide where we were defining the market, containing the market, testing the market, and validating the market. This slide shows you, in a look backward, the actual growth of fuel cell shipments since the roughly 2009 time frame. And the slope of that curve also very similar, and you can see a shift. In 2016, transport fuel cells eclipsed the number that were used for stationary fuel cell application. So we see that continue to grow as vehicle fuel cells now have shown a rapid rise in their actual use, and we look backwards for history as we look to predicting the market for fuel cell electric vehicles powered by hydrogen. That gives you a short market of those two reviews, marketing information and safety information. And from a, we think, a practical standpoint, Hexagon has tanks deployed on all of these applications. And in the upper left-hand side, you can see an application that has 2 tanks in place that are used for motoring a light-duty vehicle, first to be deployed here in the EU. a great shot of a large ocean of opportunities and a quick look at our headquarters in Ålesund, Norway. I invite you all to drop by B60 and also certainly to listen to our next speaker from H-Tech as we continue to learn more about the hydrogen market.
Thank you so much, Mr. Rashilla. That was great. At this point, if we have any questions from the audience, I can bring the microphone down so that we can all hear you. If people are feeling a bit shy at the moment, then they can drop by and visit Mr. Rashilla at booth B60 in order to discuss more. Thank you so much for your time, for listening, and thank you, Mr. Rashilla, for that wonderful presentation.
You're very welcome, Helen. Thank you. The water.